Hello guys, how's it going? But I think now you can hear me well. Am I audible? Can you please confirm if I'm audible? Okay, seems like it's okay. I can hear myself. Guys, I was in the university right now. I came home just now, and that's why I'm kind of wet still. My hair is soft. So today we're gonna solve all the problems of the Div2 contest. I haven't read the additional problems for the Div1 round. And we're gonna solve all of those problems today. All the problems from A to F. I believe that's I have a solution for all the problems. Tourist is reaching 4,000, really? Is it true? He won the first prize today? Nice. If that's the case, nice. Nice. Hi guys. That's really nice. I'm so happy, you know. I'm so happy that he's back on top and he's extending his own reach now. I mean, he's better than what he was previously. Some people was saying that Tourist is not as good as before when he was out of top 10, but he's showing that he's better than always right now. Okay, shall we start talking about the problems? Where is Cheyenne? I'm here. You can't hear me? I guess that's maybe the stream is not loaded for everyone. So refresh the page if you can't see me. The live stream is started. Okay. So let's start discussing the problems. What is your major? My major is computer science. Nice. Okay, let's start discussing the problems then. First, let's start with discussing problem A of Div2. To make sure everything is fine. Yes, everything seems fine. So, the first problem says that Dora has a set S containing integers. In the beginning, she will put all integers in LR into the set S. And each time she can select three integers A, B, and C from the set S such that GCD of A and B is equal to GCD of B and C is equal to GCD of A and C is equal to 1. Then she can remove these three integers from the set S. What is the maximum number of operations that she can perform, or you can perform? In this problem, you should perform the operations. So the main point in here is that you have all the integers from L to R. You have all the numbers from L to R. Each time you can pick three integers A, B, and C such that the GCD of each two of them is 1. And you can delete all of them. You have to say that what is the maximum number of operations that you can do. Well, the first thing that you can say in here is first thing first, from each three numbers, that you choose, at most one of them can be even. At most one can be even. So from every three numbers, at least two of them must be odd. At least 2 of them should be odd, and at most all 3 of them are odd. And the number of even numbers from each 3 numbers is at most 1. That's obvious, because otherwise if you have 2 even numbers, the GCD of them is not 1 anymore, because they have 2 in common. So basically the first thing that we can say is that the number of from the 3 numbers that we choose, at most 1 of them can be even. This gives you the intuition of solving the problem. Why? Because the number of even numbers and odd numbers are almost the same. For example, assume that we have x odd numbers and x even numbers. Well, in fact, it's possible that when we have x odd numbers, we have either x minus 1 even numbers, or x even numbers, or x plus 1 even numbers. So the number of odd numbers and even numbers differ by at most 1. Now, for example, assume that we have x odd numbers and x even numbers. It's easy to see that the number of operation would be at most x half. Why the number of operations will be at most x half if you have x odd numbers? Because each one of them, in each operation, at least 2 of the numbers are odd. So you can say that when you have x odd numbers, the number of operations that you can have is at most x half. You cannot have more than that. And it's easier to also say that, and assume that x is the number of your odd numbers. So even numbers are either x minus 1 or x plus 1. And so the answer is definitely at most x half and floor of x half. Because if x is even, the answer should be in a way that if you multiply it by 2, it would be less than or equal to x. So it should be at most floor of x half. And then I can say that x half is also possible, because if you consider all the odd numbers that we have, we can group them 2 by 2. For example, we can group these two, and these two, and this one will be left over when we have odd number of odd numbers. And then you can each time choose these 3 consecutive numbers, these 2 odd numbers with the even number in between them. You can choose these 3. And in here you can choose these 3. And here you can choose these 3. And here you can choose these 3. Then it's like each time you choose 3 numbers like this, 2k minus 1, and 2k, and 2k plus 1. The numbers you choose in each operation is of this form, 2k minus 1, 2k, and 2k plus 1. And it's easy to see that when your 3 numbers are of this form, their GCD is definitely 1. For this pair, it's easy to see that the GCD of these 2 is 1, because their difference is 1. When the difference is 1, it's a well-known fact that the GCD of x and y is equal to, if for example x is greater than y, is equal to the GCD of x minus y and y, if x is greater than or equal to y. And GCD of 0 and everything, GCD of 0 and x is equal to x. So if x is greater or equal to y, it's a well-known fact that GCD of x and y is equal to GCD of x minus 1 and y. So then difference of these 2 is 1, GCD of 2k minus 1 and 2k, based on this fact, is going to be equal to GCD of 2k minus 1 and 1, which is 1. Also GCD of these 2, is 1 with the same reason. And GCD of these 2 is also 1, because it's GCD of 2k minus 1 and 2k plus 1, which is equal to GCD of 2k minus 1 and 2, because 2k minus 1 is an odd number, this is 1. So GCD of all 3 of them, when you choose 3 consecutive numbers and the middle one is even, the GCD of each 2 of these 3 numbers is 1. Therefore, the answer really is the number of odd numbers divided by 2. Does this make sense? Is it clear? What is x and y? X and y are 2 arbitrary numbers. I'm just saying a general fact. I'm saying that for each for two arbitrary numbers like x and y, GCD of x and y. And this notation, I mean, when we write x and y like this means GCD. I mean, this is GCD of x and y. In number theory, sometimes when we want to calculate GCD of two numbers, we just write these two numbers inside brackets. Right? So I'm saying that for each x and y, for each two arbitrary numbers x and y, GCD of x and y is equal to, for x greater than y, is equal to GCD of x minus y and y. These two are equal. Therefore, I use that to show this GCD of each two of these three numbers are 1. Therefore, when we choose three numbers, the key point is this. If you choose three numbers of this one, 2k minus 1, 2k, and 2k plus 1, the GCD of each two of them is 1. GCD of each two of them is equal to 1. So the answer is really equal to the number of odd numbers divided by 2. Is it clear? It's not necessarily n divided by 4. I mean, you cannot only calculate it by the length of the array. I mean, you should consider the number of odd numbers. The number of odd numbers is important. Yes, each time we pair 2 odd and 1 even. We pair 2 odd and 1 even. No, the two odd numbers we have are 2k minus 1 and 2k plus 1. Our numbers are like this. We have, yes, in general, it's possible that we have two odd numbers that their GCD is greater than 1. But what I'm saying is that if we have two even numbers, their GCD is definitely greater than 1. Definitely. Oh, sorry. Definitely greater than 1. But if we have two odd numbers, we're not saying that the GCD is always 1. If we have two odd numbers, it's possible that the GCD is 1 or the GCD is greater than 1. So I'm saying that if you have two odd even numbers, their GCD is obviously greater than 1. But if you have two odd numbers, there is a chance that their GCD is 1. So I'm not saying that for any two odd numbers, their GCD is 1. I'm saying that if you have two odd numbers, it's possible that their GCD is 1. So from the three numbers, we cannot have more than one even number. But we can have, we possibly can have more than one odd number. This is what I'm saying. Okay. And then I'm saying that, okay, so from each three, do you agree with this? From each three, at least two of them are odd. And at most one is even. Do you agree with this? Do you agree with it so far? If you agree with it, please use this emoji. I'm not sure if you can see the emoji well. This 100 emoji. Nice. So from each three numbers, at least two of them are odd. And when two of them are odd, what we can say is that the answer is gonna be at most the number of odd numbers, CNT of odd, divided by 2. The answer will be at most the number of odd numbers divided by 2. It cannot be greater than that, because each of the groups consumes 2 of my odd numbers. When it consumes 2 of my odd numbers, the number of operations that I can have is at most the number of odd numbers divided by 2. And it's definitely the floor of this. So if the number of odd numbers is odd, it's going to be the floor of that number. Because 2 times n should be less than or equal to the number of odd numbers. So the answer is at most this much. And then I show that, do you agree that the answer is at most this much? Are you okay so far? No, it's not r minus l divided by 4. it's not based on the number of numbers that we have. It's based on the number of odd numbers we have. It's possible that in two cases we have the same number of numbers, I think, but in one of them we have more odds compared to other one. Although if that case is important or not is something that maybe R minus L divided by 4 in the cases that we consider is going to be the same. I don't know that. But what I'm saying is that the answer is going to be the answer is going to be the number of odd numbers divided by 2. Okay. So basically I'm saying that we have some odd numbers. Each of these pairs consumes 2 of them. Now consider all these odd numbers. These are all my odd numbers. I'm saying that each time I can choose 2 of them and pick them with the even number in the middle of them. Then my groups are going to be of this form. Each group, for example, this is 2 and 1 and 3. This is, for example, 6 and 5 and 7. This is, for example, 10 and 9 and 11, and so on. So each of them, you can easily see that each of them are formed of, there is an even number and the odd number before it and the odd number after it. So I just showed that for each 2 of these, the GCD is going to be equal to 1. For these 2, it's obvious because their difference is 1, so their GCD is definitely 1. When we have 2 numbers that their difference is 1, their GCD is 1. Yes, I agree that it's too much math for problem A. But anyway, I think it was a bit hard for problem A. And then for these 2, their difference is 1, therefore their GCD is 1. And then for these 2, their difference is 2, and they're both odd numbers. As I said, GCD of 2k minus 1 and 2k plus 1, based on what I said here, that GCD of x and y is equal to GCD of x minus y and y, if x is greater than or equal to y. So in here, 2k plus 1 is greater than or equal to 2k minus 1, so this is going to be equal to GCD of 2k minus 1 and 2, and because 2k minus 1 is an odd number, this GCD is equal to 1. In other words, if you consider 2 consecutive odd numbers, their GCD is always 1. So the point is that if x and y, or let me say it like this, if y is equal to x plus 1, then GCD of x and y is 1. If x and y are odd and y is equal to x plus 2, also GCD of x and y is 1. So these are the two things that we proved. We showed that for 2k minus 1 and 2k plus 1, their GCD is 1, and for these 2 consecutive numbers, that we have these 2 pairs of consecutive numbers, we have their GCD is also 1. Therefore, we can say that in total for every pair, the GCD of the numbers is going to be equal to 1, and each of the 3 each time that we pick 3 numbers, their GCD is going to be 1. Is it clear? Let me get back to the screen. If you are okay with that, we will move on to problem B. Otherwise, we will talk more about problem A. No, I didn't participate in contests. As I said, I was in the university. Nice. So Discord server link is invalid. Let me send the Discord server link again. It's valid. If you want to join our Discord server, you can join here. And also, if you want to join our Telegram channel, you can join here. And if you don't have a Telegram account, maybe you can make one, because I don't know if you heard the news about the owner of Telegram, Paul Durov. So you can support him by joining Telegram if you want. So Let's move on to problem B. Yes. Okay, let's move on to problem B then. So, index and maximum value. It says that after receiving yet another integer array a1, a2 to an as a arbitrary third party, index decides to perform some operation on it. There are m operations, and in each operation she is going to do this. Either choose plus and L and R, I mean the plus sign and L and R, then for every every integer between L and R, you will increment the value of that element. So for each AI from L to R, AI will be incremented. Or you can choose minus L and R, then for every number from L to R, for every value between L and R, that value will be decremented. So you have to see that after each operation, you have to say that what is the maximum array that will be left in our array. So what is our current maximum number? I personally believe that this problem B was kind of easier than problem A. Yes, because there's just one fact. There's just one fact that will destroy this problem. If you use this fact, the problem will be destroyed and it would be so simple. The point is that if you consider, I mean just initially, if you consider the max element, if you consider the element that has the maximum value, consider the maximum elements, that element will always remain as the maximum element. That will always remain as maximum. So the point is, if you consider the maximum number, whatever it is, that element always remains as maximum. I mean, your maximum is always that element. It's never possible that some other element would become strictly greater than it. It's possible that the rest of the values become equal to it, but no value can be strictly greater than it. Because the point is that you cannot jump in here. Each time you can choose an L and R and increase them by 1, or choose an L and R and decrease them by 1. So assume that this is your max value. For example, this is 7, and this is another value like 5. Assume that right now this is maximum. Assume that at some place this one will become greater. This 5, this value that is currently 5, becomes greater than that 7. But the point is that because we cannot jump, if this one is going to be greater than this one at some place, before that they must become equal. I mean, one cannot jump over the other value. If this is greater than this, if this one wants to become greater than it, at some point they need to become equal first. And when they become equal, then they are equal forever. They will remain equal forever. So the point is that because we don't have jump, if this one is less than this value, it always remains less than or equal to that value. So the maximum always remains as the maximum. This will never change. The maximum number will always remain as maximum. So once you know this, the problem is easily solved. Just pick the maximum. For example, consider this case. What is the maximum value in here? Is this 3. Now for each operation, see that what is the effect of that operation on this maximum value. For example, we have plus 1 and 3. And our number is 3. Our maximum is 3. We know that the effect of this operation on our max, this will have effect on our maximum. It will increase it. So our maximum turns into 4. And because we know that this element always remains as maximum, it's never possible that some other element becomes greater than it, is strictly greater than it. It's just enough for us to keep track of the current value of this index. So once this fact is proved that if you consider the maximum elements, this always remains as maximum, then we just need to keep track of that element. This is 3, this always remains. This is 3, this is the maximum, and this will always remain as maximum. So we only need to keep track of this one. When we have plus 1 and 3, this will be increased, so it becomes 4. So the answer to the first one is 4. Then we have minus 2 and 3. Our element is 4. Our maximum is 4 now, so it has no effect. Then we have plus 1 and 2. It has no effect, so it remains as 4. Then we have plus 2 and 4, so it becomes 5. It becomes 5. Then we have minus 6 and 8. 5 is not in that interval, so it has no effect. It remains as 5. Again, in the next one, our maximum is 5 initially. So we have the first operation. We have add from 1 to 4. So it has no effect on 5. As you see, another element becomes 5 as well. So it becomes equal to our maximum. But it cannot become greater than our maximum. It just becomes equal, but it cannot become greater. Because once these two are both 5, they will remain the same forever. I mean, each operation will not change, and they will forever remain the same. So I don't need to worry about this one, because I know that none of these elements can become strictly greater than me. I just keep track of my own value. Maybe they will become equal to me, but they cannot get better than me, get greater than me. So I have this 5. After the first operation, it remains as 5. After the second operation, still it remains at 5, because 5 is not in this interval. Then we subtract 1 from the elements from 4 to 5. So 5 will be subtracted by 1. It becomes 4. Then we have minus 3 and 3. It has no effect. Then we have minus 2 and 6. So my value becomes 3. So this is how we do. Each time we have a value mx. We know that what is my current maximum. We can name it as car _ max. And then when we get an L and R, we say that if car max was between L and R, we will apply this operation. If it is plus, we will increase car max by 1. If it is minus, we will decrease car max by 1. And then after that, we just see out car max each time. And that's going to be all. And this way, this problem is going to be solved. So the point is that by doing this operation on just the maximum, we always have the maximum. And by using this fact, as I said, the problem is destroyed and it's easily solved. Is it clear? Well, thank you, Hadi. Well, in fact, guys, if you want to support my work, you don't need to do this, but if you can like the video or subscribe to the channel, I think it would help me, and I would really appreciate it if you can do that. But you do not really need to do this. So, yeah, sure. In our topic streams on Friday, guys, every Friday, I don't know if you're aware of that or not, but every Friday, thanks a lot, guys. It really means a lot. Thank you. Every Friday we have a topic stream. Right now we are on graph algorithms. Previously we were doing the dynamic programming. Let me send you the link of them. In future we will cover number theory and other stuff as well. So right now we have done DP and graph. We are right now in the middle of graph, and we will get back to DP and graph as well. And our next session is problem solving on graph. So I will pin this message. If you want, you can see that. And if you had any comments about that, etc., you can say that in Telegram or in Discord to me. And we will cover the number theory for sure. So, and if you want additional problems, just let me know as well. I will try to put additional problems in Telegram or Discord as well. So shall we now move on to problem C? Yeah, as I said, I will cover math in the next topic streams on Friday. on Fridays. Nice. So let's now move on to problem C. Okay, so the problem C states that Dora has just learned the programming language C++. She did not completely understand the meaning of C++. Each time, this problem is so much mathematics and number theory as well, like the problem A. You can choose an integer I such that I is between 1 and n and increase C sub I by A, or choose an integer I such that I is from 1 to n and increase Ci by B. A and B are constants and they can be the same. And you want to minimize the range, you want to minimize the difference between the maximum value and the minimum value. You have to say that what is the minimum value that you can achieve, minimum range that you can achieve. So this problem, as I said, is also number theory, and there's some lemma. Is it lemma or is it theorem? Maybe it's a theorem. It's called Bézout's. It's a theorem. So we have some theorem named Bézout's theorem. I think T is not pronounced, so it's Bézout's theorem, and it says this. It says that if you have two numbers like A and B, if their GCD is equal to G, there exists two values. You know, it seems like too much, but it's simple. I mean, at the beginning when I'm explaining it seems too much complex, but when I explain it, it would be easier for you. There exist two integers like x and y such that x times A plus y times B is equal to G. In other words, what does it mean? It means that, for example, assume that you have two numbers like 15 and 21. Their GCD is 3. What it is saying is that you can choose two numbers, you can multiply 15 by something and multiply 21 by something else, such that when you add these two numbers, multiply 21 by something and add that by a multiple of 15, the result will be 3. Obviously, these numbers can be negative as well. So in other words, it says that if you have two numbers, you can make, by multiplying them by different numbers, you can make any multiple of their GCDs. Assume that you have two numbers, you can multiply them by anything you want and then add them. It says that you can make any multiple of their GCD. So in simple words, assume that you have two numbers A and B, and you can pick any amount of A that you want. You can pick some amount of A, and this amount can be also negative. For example, you can pick X A's and some amount of B. Like Y. For example, you can pick X A's and Y B's. For example, you can pick, 5 21s and minus 3 15s. Then the number that you will get is 5 times 21 plus minus 3 times 15. It is gonna be 105 for 5 times 21 and minus 45. It's gonna be 60. The answer is gonna be 60. If you do this, you can always make all the multiples of GCD of X and Y, GCD of A and B. So the point is that you can, if you do this operation, first of all, it's obvious that you cannot make anything that is not a multiple of 3. Because both of these numbers are multiples of 3. Both of these numbers are multiples of 3. So however you multiply them by some value and add them, the answer is going to be multiple of 3. And what Bezout theorem states is that you can make every multiple of 3. All the multiples of 3 can be made. The name is Bezout theorem. I think this T is not pronounced, I guess. So it's Bezout theorem, and it says that if you pick 2 integers, and you can pick some amount of the first one and some amount of the second one, you can pick integer values. But they can be negative, positive, 0, they can be anything like that. You can make all the multiples of 3. For example, in this case, if you have 15 and 21, you can make all the multiple of their GCD in general case. Okay, so that's the point. In here also you kind of have the same. You kind of have the same thing. You know, if you see for each number, it's like for each number you can add them by some amount of A's and also add them by some amount of B's. So you kind of have the similar structure. So you have AI or CI to be more precise. You can add it by A or add it by B each time. So it's like CI will be added by X A's and by Y B's. The only difference is that in this case X and Y still are integers, but they must be non-negative. They cannot be negative like here. In here we assume that X and Y can be negative as well. But in this problem X and Y are not going to be negative. But that's okay. I mean, we will see that doesn't cause any problem in here. So the point is that, as I said, when you have 2 numbers like A and B, you can make all the multiples of their GCD. And obviously, you cannot make anything that is not the multiple of their GCD. For example, assume that in here, if you have this A and B, assume that A and B are both multiples of 15. Then multiples of 15. For example, A is, I don't know, like 45. B is like 75. So they are both multiples of 50. And the point is that by adding A and B, CI modulo 15 will never change. So the point is that if you consider the multiples of 15, you cannot change the number modulo 15. So what I can say is that CI, if you consider GCD of A and B and call that as G, the point is that CI modulo G would never change. This will never change, would never change. So it always remains the same. CI modulo G always remains the same, but the point is that assume that for a second X and Y can be negative as well. X and Y for a second, let's assume that X and Y can be negative. Then I'll show you that doesn't change anything. I mean, X and Y, if they can be negative or they can't be negative, I'll show you that doesn't make any difference. Because at the end we care about the differences of the values, not what they exactly are. We care about what is the difference of this number and this number. We don't care about the actual values. But for a second, assume that X and Y can be negative as well. What does it mean? It means that you can subtract by A or subtract by B as well. So assume that X and Y can be negative. Then based on this Bezout theorem, but with A's and B's, you can make every multiple of G. So for each CI, you know that CI modulo G remains the same, but you can add it by G as you want, add or subtract G as you want. So it can be any number that's modulo G is this. So the only thing that should remain the same is CI modulo G, CI modulo GCD of A and B. The rest of the things doesn't matter. It can be any number such that CI modulo G remains the same. It's what it is right now. Okay. If X and Y can be negative. But now also the point is that if X and Y can be negative, assume that the X and Y's that we choose for each index, like CI, Now I want to show you that being negative and not being negative, it doesn't matter. So we show that if they can be negative, each ci for each, let's say for each ci modulo g does not change, but everything else can change. Everything else, but there are, it's better to say but there are no additional constraints. There are no additional constraints. So about, for each ci, we know that if x and y can be negative, ci modulo g does not change, but there are no additional constraints. Now I want to show you that if x and y cannot be negative or they can be negative, the final answer does not change. So we can assume that x and y can be negative. Okay, so how do I say that? If x and y are negative or they cannot be negative, it doesn't matter. The point is that for each ci, you have some xi and you have some yi. I mean, for each ci, xi times you have increased it by a, yi times you have increased it by b. And xi and yi can be negative. Assume that your numbers can be negative. Consider the minimum number you have. I mean, the greatest negative number. I mean, the negative number that is absolute value is the greatest. For example, for some I, xi is, for example, minus 100, for example. This is the negative number with the greatest absolute value. The point is that because at the end we care about the differences of the number, we care about that what is the differences of different numbers, you can increase all xi's by hundreds, and then all of them will be non-negative. So I wanted to show that if x and y can be negative or cannot be negative, the final answer is going to be the same. Because even if they are negative, okay, assume that what is the minimum negative number that you have. Then increase all the numbers by that much. This way, all the numbers will be shifted to be greater, so the differences does not change. The differences do not change. Okay, so let me summarize it and say that from the beginning again. We stated something named Bézout's theorem, and we said that it says that for each a and b, if you can multiply a by some x and multiply b by some y, you can make every multiple of their GCD. By this, you can make every multiple of their GCD. Let's call that G as GCD of A and B. So now the point is that when in this problem, you can choose each time for each CI, you can choose to increase it by A or increase it by B. For example, assume that you have increased it by A x times, increase it by B y times. Then your final number is going to be CI plus x times A plus y times B. This has a very similar structure to what we've seen in here. But the only difference is that in here, x and y could also be negative, but in here, x and y cannot be negative. But I say that, okay, don't worry about it. Let's for a second assume that x and y indeed can be negative. Let's remove that additional constraint that x and y cannot be negative. Then if they can be negative, based on Bézout's theorem, we know that basically Ci modulo G cannot change because each time we are adding A or adding B or subtracting A and B. So modulo G, the number does not change. G is the GCD of A and B. Modulo G, nothing would change. But there are no additional constraints because we can make every multiple of G. We can make every multiple of G. So modulo G, it must not change, but everything else is okay. I mean, we do not need to worry about anything else. And now I say that when we have this situation, the only thing that we care about is that what is this number modulo g, and I show that at the end it doesn't matter if x and y can be negative or cannot be negative. Assume that when x and y can be negative, assume that what is the most negative number? I mean, what is the negative number with the maximum absolute value that we have? For example, assume that some xi is minus 100, and this is the least possible value, minus 100. You can shift all the numbers by 100 so that all of them can become non-negative. So if you have some negative numbers, you can shift all of them upwards so that all of them will become non-negative. And by doing that, nothing changes, because at the end we care about the differences of the numbers, not the numbers themselves. At the end we care about maximum and minimum. When you shift all of the numbers in your array will be shifted by the same value. I mean, they will be increased by the same value. So the range does not change. So it doesn't really matter if your numbers x and y can be negative or cannot be negative. Okay. Is it clear so far? If you are okay with that, please use this. Put a plus in the chat. If it is not clear, please use a minus in the chat. It's completely okay. It's not if it's not very clear for you. Yes, as discussed before, maybe you need to first learn about Beza theorem. I tried to explain Beza theorem in a limited time, but maybe you need a longer form of video to explain that. And as I said, in the future topic streams, we will get into it and we'll discuss it. Code, I have not implemented this code by myself, but maybe we can take a look at some codes. I mean, the code is not complicated at the end. These are the theoretical parts. These have no effect on the code. The code is what I'm gonna say right now. What I will discuss right now is the parts that is important in code. But so far, what we said was theoretical. That helped us to prove that why our answer is correct. Okay. Well, as I said, the idea is to use Beza theorem. I mean, this problem, because each time we are adding numbers by a and b, we see that it has a very similar structure to that what I was saying before. I mean, when you can increase it by a, like x times, and increase it by b, by y times, well, the first thing that should come to your mind is that modulo GCD of a and b, that number would never change. And then it's also, if you are familiar to Bezu, it's also easy to conclude that you can make everything with that value. I mean, if you assume that, first of all, if you consider that you can have negative values, nothing would change. I mean, it's okay if you consider you have negative values, and if you can have negative values, so from now on, you know, we showed that if we have negative values, if x and y can be negative, the final answer wouldn't change. If x and y can be negative, the final answer wouldn't change. So from now on, when the answer does not change, from now on, we assume that x and y can be negative. Okay, so now from now on we assume that we showed that if x and y are negative, the final answer wouldn't change. So when the final answer wouldn't change, let's assume that x and y can be negative. Okay? And when x and y can be negative, as I said, the only point is that for each index, we know that what is it modulo g. What is this number modulo g? For example, assume that g is 5. Or let's take a real example. For example, in the first case, g is really 5, but let's take other examples as well. Let's consider this example. For example, 477, we have, let me first write it in here and then we will switch to tablet. We have 4, 7, 7, and then 1, 1, 2, 6. So the point is, in here, we know that a and b are both 7. And GCD of a and b therefore is also 7. So the numbers would not change modulo 7. The only thing that we care about, and as I said, x and y can be negative as well. So we assume that we can subtract by a and b as well. Because we showed that that wouldn't make any change in the answer. So if it doesn't make any change, so let's assume that that is also possible. We can also subtract by a and b. Therefore, we can state that the only condition about the first number is that modulo 7, it must be 1. So it's of form like 7k plus 1. Modulo 7, it must be 1. That's the only condition about the first one. The only condition about the second one is that modulo 7 is 1. The only condition about this one is that modulo 7, it must be 2. This one, modulo 7, it should be 6. So if you consider all the possible values that each number can have modulo 7, the numbers can be from 0 to 6. They can be 0, 1, 2, 3, 4, 5, and 6. So we have a number that modulo 7 is 1. We also have a number that modulo 7 is 2. And we also have a number that modulo 7 is 6. So we have these numbers. And at the end, the point is that we need to set them next to each other such that the difference between maximum and minimum will be minimized. Is it clear so far? I mean, are we on the same page so far? And it doesn't really matter that how many of each of, I mean, it doesn't matter that how many numbers do we have with such that the modulo 7 they are 1. That doesn't matter at all. It just matters that we have a number that modulo 7 is 1. When we have two of them, we can put both of them to be the same. Then the second one has no effect. Okay, nice. So, we know that we have a number that modulo 7 is 1. We have a number that modulo 7 is 2. And we have a number that modulo 7 is 6. Now, if we set this one as minimum, if the number that modulo 7 is 1 as minimum, then our maximum in the best case scenario will be, is the difference. The maximum is going to be this one, and the difference to it, the distance to it is going to be 5. So if the minimum is the 1, if the minimum is the number with the form 7k plus 1, our maximum must be 7k plus 6. So the difference is going to be 5. What if this one is minimum? What if this number is minimum? Well, if our minimum is a number of shape 7k plus 2, then our maximum is going to be this one. I mean, because if we move in the clockwise order, the farthest one from this 2 is this one. Why? Because if 7k plus 2 is the minimum, this value is going to be at least 7 times k plus 1 plus 1. Because it cannot be, I mean, this value of k it cannot be the same as k for this one. Otherwise, it was less than 7k plus 2. So in the least case scenario, it must be 7k plus 1 plus 1. Therefore, the distance would be 6. So if this 2 is the minimum, the farthest one, the point is that you need to go in the clockwise order and see that what is the farthest number that you see. If that number is our minimum, the maximum difference is that the last number that you can see in the clockwise order. And if our minimum is this 6, then our maximum is going to be this 2. I mean, if our minimum is 7k plus 6, the maximum is going to be 7 times k plus 1 plus 2. And the difference is going to be 3 in this case. So in here, our answer must be 3. And as you see, it is 3. And how can we make this 3? We can make this 3 when this 6 is gonna become our minimum. And how can we make this 6 our minimum? We can keep this one as 6, add 7 to this one. When this 6 is minimum, these values must not remain as 1 and 1 and 2. They must be increased so that they're gonna become greater than 6, because 6 is our minimum now. So this one is at least 8, this one is gonna be at least 8, this one is gonna be at least 9. And this way the difference will be 3 at the end. So the point is that when you find G, your numbers modulo G are gonna have some values. For example, it is either 0 or it's gonna be 1 or 2 or 3 or to G minus 1. These are your numbers modulo G. You have some possible values for your number modulo G, and some of them are chosen. Some of them we have some value with that value modulo with that specific remainder to G. The point is that each time you can choose one that is your minimum and your maximum. If this number is the first number, your maximum is going to... The point is that the maximum is going to be the next element in the counterclockwise order. For example, when 1 was the minimum, in the counterclockwise order, the next one to it is 6. So this 6 is going to be the maximum. If 2 is your minimum, your maximum is going to be 1. If 6 is your minimum, your maximum is going to be 2. So it's like if you have them in a vector, if vec of I is going to be your minimum, vec of I minus 1 is going to be your maximum. And if I is 0, it's like vec of n minus 1 is going to be your maximum. So we can say that it's like I modulo n plus, I is always modulo n. I plus, I can say I plus n minus 1 modulo n. This is gonna, when this is your minimum, your maximum is gonna be this one. This is the next one in the counterclockwise order. For example, if 1 is maximum, 1 is minimum, this 0 is gonna be the maximum. When this one is gonna be the minimum, your maximum is gonna be this one. When this one is your minimum, maximum is gonna be this one. And so on. And when minimum is this one, maximum is this one. So each time you should see that what is the difference. And you should consider the minimum of these differences. And that is going to be your answer. I know that it was 2 numbers already, and it might have some new things for you. But I hope that you've understood. If you understood it, please put this emoji or put a plus in the chat. If you didn't, feel free to say that is completely okay. It completely makes sense if you didn't understand properly. So you can say that in the chat. If you need any part to be repeated, feel free to say that. I can show you implementation as well, that's okay. And guys, let me also tell you that if you didn't understand some part completely, you can always see every part of this live stream, even during the stream or even at the end of the stream. At the end of the stream is going to be recorded and you can see it as a video. It will be also, you can also see it in Codeforces. This problem will be added to the contest material in the Codeforces. So after the round is over, the system thing is over, in the contest materials, this video will be added, and for every problem, the solution, you can see the solution if you want. The video tutorial will be added in here. So you can always see all those parts, but let me tell you the summary one more time, so that for the people who didn't understand, I just say the summary very quickly, and then if you want, we will move on to the implementation. If you didn't want, we will move on to problem D. Okay, it's bad news. It's like tablet is not responding. So, okay, it's fixed now. So, what I was saying is that first of all, I said that there is a theorem, Bezout theorem, that if you have A and B and you can multiply A by anything and B by anything by integer values that can be negative or 0 or positive, you can make every multiple of GCD. As I said, the details, I mean like the proof, etc., will be covered in topic streams. Once we will go over this topic and we will completely explain that how how Bezout theorem can be proved and how is it useful. For example, you see one of the problems that this theorem was useful, but you need to understand maybe its concept more deeply and know the proofs, etc. So I think we need a dedicated topic stream for that to discuss it completely. So we know that every multiple of GCD can be added. So when we have, and we prove that when we know that each time we can choose a CI or add A or add B to it. And then I showed that even if we can also subtract A or subtract B, the answer wouldn't change at the end. Because you can see that what was the maximum number of times that you subtracted something, you can shift everything upwards so that all the numbers become non-negative, and still the difference between maximum and minimum wouldn't change. So if we can subtract the final answer wouldn't change. So let's assume that we can also subtract. So when we showed that the answer wouldn't change if we have that, so let's now assume that we can subtract. Because why we assume that? Because it makes everything cleaner and it's easier to talk about our intuition and our arguments that way. So let's assume that we can also subtract. So when we show that the answer wouldn't change if we can also subtract, and if we can also subtract, everything is cleaner to think about the problem. You should just consider that, okay, you can also subtract, because this will help you to get the solution faster, because this way everything is going to be cleaner and easier to comprehend. So now that you can also subtract, we know that we can add each number by G or subtract each number by G, because we know that there is some formula. For example, we can add G if we can add A x times and add B y times, and they can be also negative. We know that there exists some x and y, that x times A plus y times B is going to be equal to G. So we can make G using some formula, some number of A's and some number of B's. So we can freely, for each CI, add it by G or subtract G from it. Therefore, the only condition is that CI modulo G wouldn't change. But everything else can change. CI modulo G would never change, but there are no additional constraints. We can add as many G's as we want to that. So the only thing that matters is that what is the value of CI's modulo G. It's going to be from 0 to G minus 1. We will mark all of them, all of those cells, that we say that, okay, these values, I mean these remainders are in our elements, and say that, okay, which one of them is going to make the minimum. If this one is going to be minimum, then we have to set everything else as the minimum possible value that is going to be greater than it, because this must be the minimum. So the point is that if we set the minimum, this one minimum, in the best case scenario, the maximum, the least maximum that we can have is the one before it. This one is going to be the maximum. And we should see that what is the difference from that one to this one. And between all those values, we will take the minimum. And that is going to be our final answer at the end. Is it completely clear now? So this was a summary of the solution. If it is clear, please once again use this emoji or put a plus in the chat. If it's not, as I say, you can always watch these parts again. So maybe for now it's better if we move on to the next thing, because I'm sure that some of you want that. But you can always view the video again. And as I said again, if you wanted to have further discussion, you can join our Telegram channel or our Discord server for further discussions. Yeah, you're welcome. Thank you very much. Why is the last case not covered by the GCD of A and B? What do you mean by the last case? Explaining the part of taking mean and max. I'm just saying that, just consider that which number is going to make your minimum number. For example, in this example, when we have 1, 1, and 2 and 6, at the end, your minimum is going to be either this 1, or this 1, or this 2, or this 6. If this 1 is going to be your minimum, the difference of your minimum and maximum in the best case scenario is going to be 5. Because anyway, this one must be greater than this one. And this one modulo 7 is 6, this one modulo 7 is 1. The difference is going to be 5. If this one is minimum, the way we can do that is to keep this one as 2, keep this one as 6, and make this as 8. So the difference between maximum and minimum, if this 2 is minimum, is going to be 6. And if this 6 is going to be minimum, we should keep it as 6 and change these ones, 2 to 9 and 1 to 8. The difference between these two is going to be 3. And in this case, the answer is going to be 3. The minimum of these 3 values is going to be 3. So 3 is going to be our final answer. So this is how we can find out the final answer. Do you also need to show an implementation, or do you prefer if we move on to problem D? Nice. Welcome. Do you prefer if we also talk about a code and implementation, or do you prefer to move on to problem D? So far it's 3 by 1 in the woods, 4-1. Only 1 out of 5 wants implementation. Is there... Okay, it seems like most people want to move on, so I'm sorry for that, but I will put the link of a solution in the Telegram channel and also in the description of this video, so if you want it, you can check that out. But for now, because most of you want me to move on, maybe it's better if we do what the majority wants. Okay, so let's then move on to problem D. Let me first bring it. Why this keeps happening? Okay. So, the next problem is problem D. Iris and game on the tree. It says that Iris has a tree rooted at vertex 1. Every vertex has a value of 0 or 1. Let's consider a leaf of the tree and define its weights. Construct a string formed by the values of the vertices on the path starting at the roots and ending in this leaf. Then the weight of the leaf is the differences between the number of occurrences of 1, 0 and 0, 1 substring in it. Now at the end, some of the vertices have question marks. We don't know what is. They have question marks, and we can set that we want them to be 0 or we want them to be 1. 2 players are playing. One of them wants to maximize the number of leaves that their answer is 1. One of them wants to minimize it. You have to say that what is going to be the answer if both play optimally. So, let me just make sure. Iris aims to maximize the score, and the score of a tree is defined as the number of leaves with non-zero weights on the tree. Their weights must be non-zero. So there's one key observation again on this problem, that if you consider this, the problem would become a lot simpler. I mean, if you see the definition of weight of a leaf, it's kind of complicated. It says the weight of the leaf is the difference between the number of occurrences of 10 and 01 substrings in it. It's a very complicated thing. I mean, what does it mean? Can we somehow simplify it? Well, the point is that do you have any idea to simplify it? First of all, can you help on this problem? Exactly. The whole thing that it's talking about, a good leaf is a leaf that its value with the root is different. Its value is exactly. We should compare each leaf and the roots. Their values must be different. If the root is 0, this leaf must be 1. If the root is 1, this leaf must be 0. So let's say why. So as I said, a good leaf, this is the observation that I want to prove. A good leaf is a leaf that its value is different compared to the roots. So a good leaf is a leaf that its value is different compared to the leaf. Why? Because what does it mean? I mean, what does it mean that the differences of 1 zeros and 0 ones? If you consider a string, it has several zeros, several ones, several zeros, and so on. So it will be of this form. This is going to be, for example, a possible string that we can get if we go from a root to a leaf. The point is that we have some blocks of zeros and we have some blocks of ones. And by the way, guys, if you wanted to prove this observation by yourself, you can leave watching the video for now and just think about it yourself. That's also something that you can do if you want. I think it can help you. If you just hear this observation and then just try to prove it by yourself. And if you were stuck, then come back and watch the rest of the video. If you want, so you can try to prove it by yourself. It can be a good training. So the point is that we have some blocks of zeros and some blocks of ones. And you can see that these substrings of 0 ones and 1 zeros happen. I mean, this 0 1 only happens when we go from a block of zeros to a block of ones. This 1 0 only happens when we go from a block of ones to a block of zeros. So only when our block changes, these two substrings happen. When we go from a block of 0 to a block of 1, we see a 0 1. When we go from a block of 1 to a block of 0, we see a 1 0. So only when our block changes, one of these two happens. When we go from a block of zeros to a block of ones, 0 1 happens. When we go from a block of ones to a block of zeros, 1 0 happen. 1 0 is going to happen. So this is what is going to happen. This just shows that how the blocks will change. So each one of these two happen when we change the block. When we go from a block of zeros to a block of ones, we see 0 1. When we go from a block of 1 to a block of zeros, we see 1 0. And since these two happen alternatively, I mean, if you go from a block of zeros to a block of ones, next time you have to go from a block of 1 to a block of 0. I mean, you can never see 2 0 1s right after each other. Between 2 0 1s, there definitely must be a 1 0. Maybe that 1 0 is even this 2. I mean, for example, our string is 0 1 0 1. So then between these 2 0 1s, there still is a 1 0. So the point is that between 2 0 1s, we always see a 1 0. Because 0 1 happens when we go from a block of 0 to a block of 1. And then we are in a block of 1. So if we're gonna again have 0, 1, again we need to go from this block of 1 to a block of 0, so that in future we can have 0, 1. So the point is that in that case, between these two 0, 1s, because we are going from block of 0 to block of 1 here, and here also we are going from block of 0 to block of 1. From this block of 1, first we need to get back to a block of 0, and then we can go from block of 0 to block of 1. So therefore we can say that between each two 0, 1s, a 1, 0 will happen. And between each two 1, 0s, a 0, 1 will happen. So this will happen alternatively. I mean, first we see 0, 1, then we see 1, 0, then we see 0, 1, then we see 1, 0, then we see 0, 1, and so on. So 0, 1 and 1, 0, they will happen alternatively. It also shows that the answer, this value of a root of a leaf, is either 0 or it's -1 or +1. It's one of these three values. It's either -1 or 0 or 1. It's one of these three values. And when is it 0 and when is it non-zero? Well, the point is that if you start from a value, for example 0, or the value of the root is 0, and the value of the leaf is also 0, the point is that whenever you see a 0, 1, it means that you have gone from a block of zeros to a block of 1s. Right after that, I mean, at some point you have to get back to blocks of zeros. For example, you have blocks of zeros and you have blocks of 1s. When you go from blocks of 1s to blocks of zeros, then at some point you need to come back, because you know that at the end you will be at the block of zeros. So at the end the value you will have is 0. So the point is that whenever you see a 0, 1, you will find the corresponding 1, 0 after that. And that's the same thing when the first and the last character are both 1. Again, you are starting from the blocks of 1s, so whenever you see 1, 0, you are going to a block of 0. So right after that, at some point, there should be a corresponding 0, 1, so that with that one we'll come back to the blocks of 1s. So the first elements and the last elements, when they are the same, the number of 0, 1s and 1, 0s are going to be the same. But when the first elements and the last elements are not the same, for example, this is 0 and this is 1, the point is that at some point, I mean, we're going to go from 1 to 0 to 1 and then from 1 to 0 a couple of times. But at the end, we're going to end up in a block of 1. At the end, the last elements that we have is a 1. So the number of 0, 1s will be one more than the number of 1, 0s. So each 0, 1 has a corresponding 1, 0 except the last one. The last one does not have a corresponding value. Okay. So yes, for example, if you have this example, for example, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 0. If you consider here, for example, for this 0, 1, it says that from this block of zeros, we are going to blocks of 1s. Then it must be a corresponding 1, 0 that we get back to blocks of zeros. For example, the corresponding 1, 0 of this 0, 1 is this. Then again, we have a 0, 1 here. We are going from block of zeros to block of 1s. So first, I mean, this is block of zeros, this is block of 1s. Initially, with this red edge, we go from zeros to 1s, and then we have to come back from 1s to zeros. And then with this green one, we will go from 0 to 1, and then there is a corresponding 1, 0 that helps us to get back to the zeros. And again, after that, with this yellow one, we are going from 0 to 1, and there must be a corresponding 1, 0 that help us to come back to 0. Because we know that at the end we will end up at 0, the number of times we go from 0 to 1 is going to be equal to the number of times that we will go from 1 to 0. So the final difference of 0, 1s and 1, 0s is going to be 0 this way. Is it clear? So when the first one and the last one are the same, the answer is going to be 0. When they are not the same, the answer is not going to be 0. And then we come back to this observation that a leaf is good if and only if its value and the value of the roots are not the same. That's the main point of it. Is it clear? Does it make sense? Nice. Thank you. How to think of it? Well, you can build this intuition by solving a lot of problems. I mean, I personally, when I see this problem, this automatically comes in my mind that 0, 1 means that from a block of zeros we're going to a block of ones. 1, 0 means that it's like from a block of ones we are going to a block of zeros. Yeah, so this was the main points. So now there are two cases. Either the root is fixed. I mean, for the roots, we know that it is either 1 or 0. I mean, this is easier. If the root, for example, assume that the root is 0. Then we want to make, and we only know that only leaves matter. The other vertices, the vertices that are not leaves, only the root and the leaves matter. The rest of the vertices do not matter at all. So if the root is fixed, if you want to maximize the answer, you need to set the leaves to be 1, as many leaves as possible to be 1. If you want to minimize the answer, you need to set as many leaves as possible to be 0. So each time, if you have, for example, k leaves left that they do not have any value, sale of k over 2 will be different by the maximizer, by Iris, and her friend will set the floor of k divided by 2 to be 0. So it's obvious that how we can calculate the answer from all the leaves. From the leaves that their value is set, we can see that how many of them are different to the roots. From the rest of them, the floor of the rest of them divided by 2 is going to be different. The other ones are going to be the same. So in this case is easy. This case can be easily calculated. But what if the root is not fixed? What if we have a question mark in the root? Well, again, there are two cases. If for the leaves, we have the same number of leaves with 0 and 1s, or we have different number of leaves with 0 and 1s. For example, assume that we have only 1 0 and we have 3 1s, and the rest of them are question mark. Well, then for Iris, it makes sense that she, in her first term, makes the root to be 0. Because there is difference in the number of leaves that are 0 and the number of leaves that are 1. When this happens, it's better for Iris to make the leaf to be 0. Otherwise, then in the next term, her friend might make the root to be 1, and she will lose these 3 1s, and she has to stick with just this 1 0. So if the number of zeros and ones are different, it makes sense for Iris that in her first move, she makes the root to be the color that gives her the maximum answer so far. But if they are the same, for example, we have 2 zeros and 2 ones. Well, in this case, it's better to not be the first player. It's better if you are not the first player. So the point is that if you are the first player, for example, if Iris goes first, if Iris sets this 1 0, then in here it's the best. For example, assume that there are 3 other vertices in here. If Iris sets this 1 0, I mean if any of them sets the root to be some value, the other player can change 2 of these 3 vertices, can set 2 of these vertices, but that player who set the root can only choose 1 of them. This happens in one of the examples. I mean, if you just consider this example, I think it was this example. 1, 2, let me draw the 3. 1, 2, 2, 3, 3, 4, and 5 and 6. And only for 2, we know that the value of 2 is 0, but the rest of them are question marks. So we don't know the roots, and the number of zeros and ones in the leaves are the same. They are both 0. There are no leaf with value 0 and there is no leaf with value 1. So there are, both of them are 0. I mean, we have none. So now the point is that if you go first, if Iris sets, if whoever who choose one of these 4 vertices first is worse for her. Why? Because the point is that if you choose one first, for example, if you set the root first, the other player can pick 2 of these leaves and you pick only one of the leaves. And if you first change one of these leaves as well, for example, set this leaf to be 1, for example, then the other player can choose the leaf accordingly in her next turn, choose the leaf such that it is better for her. And then again, it's bad for us. It's bad for the one who has chose this leaf. So the point is that in this case, both players try to set the important vertices as late as possible. They try to not be the first player who sets one of those important vertices. So in this case, for example, if you consider this sample, Iris goes first, and Iris does not want to set one of these important vertices. So she will choose the 3 and set value of 1, for example, for it. It doesn't matter. Either 1 or 0, it doesn't matter. Because vertex 3 is not important. It's not a leaf and it's not the root. And then the other player can go first. The other player either should set the roots and then Iris can set 2 of these 3 leaves. Or the other player will just change the value of one of these leaves. For example, set this one to be 0. Then when she sets this one to be 0, Iris can set the roots to be 1. And then again, other player can choose one of these ones and set them 1 so that it's the same with the root. And Iris can choose another one and set them to be 0. Then the answer this way is going to be 2. So the point is that in this case, whoever who goes first is worse. It's not better for you to go first. So you try to use the other vertices that are not important first. And if there are odd vertices that are not important, it's better for Iris because the second player is gonna be the one who's gonna need to do the first move, the first important move. But if there are even non-important vertices, at the end Iris has to go first in these important vertices. So the point is that there were several cases. If the root is fixed, it's easy. Both players alternatively play, and each time they will try to choose one of the leaves and set their value to be what they want. Iris wants to set them different to the roots. The other player, her friend, wants to set them equal to the roots. If the root is not fixed, if the number of zeros and ones are different, then Iris in her first move sets the roots to whatever is better for her. If they are the same, if the number of zeros and ones are the same, the point is that for both players, it's better for them to not do the first move. For both of them, it's better to avoid doing the first move. Therefore, both of them try to use non-important vertices and set them. And when they do that, at the end, if there are even number of non-important vertices, then Iris is going to be the one that has to do the first move on the important vertices. If there are odd number of them, her friend must go first. For example, in this case, there were odd number of non-important vertices, so it was better for Iris. Iris could do that, and then her friend had to go first in these important vertices. Therefore, Iris can have 2 as answer. Otherwise, if Iris was going first, then the answer would be 1. Because if Iris, for example, choose the roots, then her opponent, her friend, will choose 2 of them and set them equal to the roots. Or if Iris sets one of these leaves, then her friend could set the roots to the other value, and then again the answer would be 1. So this is how problem D can be solved. Is it clear? Does it make sense? If you are okay with that, please again put a plus or use the emoji. Nice. Thank you very much. Thank you. Nice. Happy to hear that. And guys, again, if you like the video, you can always support my work by liking the video or subscribing to the channel. That would really help. As I said before, you do not need to do that, but if you do, I think that would really help. So now, shall we move on to problem E? Nice. Okay, so let's move on to problem E, iris and the tree. It says that given a rooted tree with the root at vertex 1 for any vertex I in the tree, there is an edge connecting vertices I and Pi with a weight equal to Ti. Iris does not know the values of Ti, but she knows that the sum of the values of Ti's is equal to W. And each of the Ti values is a non-negative integer. The vertices of the tree are numbered in a special way. The numbers of vertices in each subtree are consecutive integers. In other words, the vertices of the tree are numbered in order of a depth first search. Now we define distance of u and v as the length of the simple path between vertices u and v in the tree. Next, there will be n-1 events. Iris is given integers x and y, indicating that t of x is equal to y. After each event, for each I and the next value, this next value, if you consider it to be cyclic, she calculates the distances of them independently and sum them up. You have to say that what is that sum? Well, now that I'm reading this statement again, I see that I did not really use the fact that these numbers are in order of a depth first search. I hope that this doesn't make my answer incorrect, but anyway, let me explain to you that what was in my mind after reading this problem. So guys, what I say is that the main thing in this problem is that if you consider each of the vertices, you need to do this. You need that for each x and x plus 1, you want to see that what is the maximum value that they can have. And if x is 1, if x is n, x plus 1 is 1. So it's a cycle actually. I just don't want to write those mods, etc. in here. So let's just assume that this plus 1 is a cyclic operation. If x is n, x plus 1 is 1. So we want to see that the maximum sum that can be here. This is now 4,000. That is an interesting thing. What happened? Let me show you something. What is this? Is it a new color or something? Tourist. Oh, tourist is now. It's very cool. So it seems like after Legendary Grandmaster you can become a tourist. Nice. It's very nice. So happy to see that. Okay, that was fun enough to make a pause between the explanation of problem E and check that out. But it seems like tourist has officially become a tourist. He's not a legendary grandmaster anymore. He's a tourist now. It seems like it is a new level from now on, and I think it's really cool. Let's see if anyone else can become a tourist in the future as well, or not. Yes, congrats to him. Okay, so we care about some x and x. We want to see that what is the maximum sum of the edges from x to x plus y. And then the point is that you need to see that what is the sum of the weights outside of this path. I mean, if some edges, their values are known, if the value of some edges are known, then they are not important. They cannot be inside of this path anymore. So if the weight of some edges is set and they are outside of this path, they cannot be in here. So the point is that you need to see, in other words, you need to see that what is the sum of these other, what is the sum of these other vertices, these other edges. Or in other words, you need to see that what is the sum of all the known edges. That's easy to calculate. The sum of all known edges is easy to calculate. We can, each time when we see a new edge, add that to an accumulated sum and keep the sum of all the known edges. And then we need to see that what is the sum of the edges in this path. We need to know that what is the sum of the edges in this path. And the point is that our answer will be at most w minus the sum of all those edges that are known plus the sum on this path from x to x plus 1. Do you agree with this? I mean, the maximum value that we can have is w minus the sum of all the known edges, because they are just known, and if they cannot be on the path, they are not on the path, we should subtract them from w. So we can subtract the whole sum and then add the edges that are in the path back again, because those should not be subtracted. Is it clear? Yes. So how many of you think that you can someday become a tourist? So now the main goal of the people is not to become a LGM. I mean, the end of it is to become a tourist. So is it clear? Is what I explained to you clear now? If it is, please use this emoji or put a plus. I guess everybody are checking CH profile right now. Yes. Okay, nice. Yeah, sure. I'm just saying that for any path that you consider, between x and x plus 1, the point is that all the edges that are outside of this path and their value is known, their value is known, they cannot be calculated in this path. So we need to subtract them, w minus the sum of all the known edges, but we should add the sum of the known edges in this path back again, because they can be added to our path. So we said that everything that is outside of this path, everything that is fixed outside of this path is not useful anymore. But if something is known inside this path, that is useful, that can be used in the path. So when we subtract some, we need to add these values back again. So the only thing that we care about is the sum of the known edges from x to x plus 1. So we can initially set everything to be 0. We can set everything to be 0, and then each time when we add an edge, update the value of that edge, and our query is to update this value of sum of x and x plus 1. Is it clear now? If it is, okay, nice. Nice. Okay, so this is the main thing. And now while I was explaining, I was thinking to somehow use the fact that these values are in the first search order, in DFS order. I think we can also use that. How? Because, you know, the point is that when you consider an edge that you have, well, the point is that when you have an edge, you know that all these values in here are an interval. So the values of the vertices in here, basically I first had a solution without using that and it was more complicated, but this can help me to simplify the solution for this problem. Assume that the indices in this interval is from L to R. Then the point is this edge will only appear in the path from L minus 1 to L and in the path from R to R plus 1. These are the only pairs of, these two are the only pairs of the consecutive numbers that if we go from a path, if we go a path from the first one to the second one, we will see this edge. So only two of the values must be updated. If for every subtree we keep track of the interval in that subtree, only the answer for two of these pairs will be updated. So we can just save that for these two pairs, the sum from, we can say that sum of L minus 1 and L will be added by, if for example the weight of this one is for example X, because W is used, let's say X. Sum of L minus 1 and L is plus equal to X, and sum of R and R plus 1 is plus equal to X. We can easily update these two. Because when it is from L to R, only two of the passes, two pairs are there that they will be updated. So we can easily update them in here. If they are different, we will add each of them. If they are the same, we just add that one by X. And this way we can easily update these sums of X and Y, and we can easily calculate the answer for each pair and just sum them up. And by summing them up, the point is that what happens to everything remains the same. From everything, this new sum will be deducted. So when we add an X, everything will be subtracted by N minus X, because we have N pairs and each will be subtracted by X. But the point is that for two of them, they will not be subtracted by X. So it's like maybe we can always just add 2X at the end. So maybe it's always will be subtracted by N minus 2X. So this way we can just update everything. Is it clear? Does it make sense? So my main thing, I'm suspecting that it can even be further simplified. It can even be simplified further, maybe. But anyway, even if you do not do that, these sums will be easily updated. It's only important that for two pair of vertices, the sum will be changed, and we can update them manually, and then the total sum can be easily calculated as well. Is it clear now? Guys, I made a horrible mistake and I made my hair short, and now I'm praying for my hair to be long, to become long again. So pray for me for it to become long. It was a horrible mistake for me to make my hair short. So, do you have any questions from me? Somebody's calling me. Yes, I hope that it will grow long soon. Yes, tourists got a new color, yeah. We were discussing it just a few minutes ago. That's really nice. And the title is also tourist. He's a tourist now. Yes, exactly. It's based on the it's the Eulerian order. It's the DFS order because we know that the indices in each subtree is in an interval. We can take advantage of that and simplify everything this way. Is it clear? Well, wait a minute. Where is this here, Manos? This picture seems like a place in Tehran. Can you say that? Where is this picture from? Is it from Iran or? Yeah, so you're Iranian? I mean, your name does not look like an Iranian, but this tower, yeah, I know that it's Azad Tower. Is interesting. I mean, your name does not look like an Iranian, but your picture is very Iranian. Oh, come on, nice. You're an Indian but lived in Iran for many years, and you have the picture of Azad Tower. Nice. Do you right now live in Iran? I'm sorry, guys, that I'm keeping you waited for this conversation. But just wanted to ask if you right now live in Iran or not. I really miss Iran right now. I haven't visited Iran for so long time. Oh, you live in Bangalore now. Yeah. Okay, nice. Yes, tourists got a new tag. If we do plus LR for more number of times, or I don't understand completely what you say. So please explain further what you mean. Guys, shall we move on to problem F? You know, this sample that you're sending is corrupted now. I mean, everything is next to each other. Shall we move on to problem F? I also have ICPC 2024 in 2 weeks. Nice. Yeah, you can visit Iran anywhere. I personally really miss Iran. Okay. Yes, it has convex hull, etc. So let's move on to problem F now. Sorry that we had so much additional conversations and kept you waited. But anyway, the next problem, area and expanded sets, it said that let there be a set that contains distinct positive integers. To expand the set to contain as many integers as possible, A can choose 2 integers x and y from the set such that their average is still a positive integer and isn't contained in the sets, and add it to the sets. The integers x and y remain in the set. So each time we can choose 2 x and y's and add their average to the set. Well, for x plus y half to be a positive integer, they must have the same parity. I mean, when x plus y divided by 2 is a positive integer, it means that x plus y is an even number. When x plus y is an even number, when x and y have the same parity. So each time we can choose 2 numbers such that they have the same parity and add their average to the sets. And let's call the set of integers consecutive if after the elements are sorted, the difference between any pair of adjacent elements is 1. Now, array likes consecutive sets. Suppose there is an array B, then array puts all elements in B into the set. And if after a finite number of operations described above, the set can become consecutive, the array B will be called brilliant. And you have to find the number of sub-arrays of your array that are brilliant. And if some element is occurred more than once, it will be counted only once in that array. Okay. Somebody is really calling me many times. I hope that there isn't an issue. So each time we can have just we have some sets, and each time we can choose 2 x and y such that the average is not in the set and their average is a positive integer, and add x plus y half or their average to the sets. Okay, so what can we say in here? Well, the point is that let's talk, we know that when we have a set, we will keep doing operations several times. Okay, yes, I will teach in future topic streams those advanced algorithms in future ones. So now let's talk about the case that we will keep adding elements until we will stop at some point. We cannot add any further elements anymore. So let's see how the array looks like, how the set looks like. So let's assume that we keep doing these operations until we can't do anymore. Until we can't do anymore. So the question is that how the array will look like when we stop. Well, the point is that first of all I can say that let's call the elements in this. How will the array, not the array, how will the set will look like? How the set will look like? Well, the point is that let's consider the numbers in the set to be S1, S2, S3 to Sk. The first thing that I can say is that Si and Si plus 1 for each I have different parities. This is the first fact that I can say. Si and S sub I and S sub I plus 1 have different parities. Why? Because assume that they have the same parities. They are both odd or they are both even. We said that we stopped. If they are both have the same parity, they are sorted in increasing order now. If both of them have the same parity, it means that we could also add one more integer in between them. So assume that they have the same parity. For example, assume that Si is 5, Si plus 1 is 9. In this case, if their parity is the same, both of them are, for example, odd, the point is that you can add their average in the middle of them. But we assume that we have done our operations many times, such that we've stopped. We cannot continue doing our operations. So we are at our equilibrium. I mean, we are at a state that we cannot make any further changes. We cannot add anything anymore. Okay? So the point is that Si and Si plus 1, S sub I and S sub I plus 1, when we are done and we cannot do any further operations, must have the same parities. Is it clear so far? Are you okay with that? If you are okay with that, please use this emoji again or put a plus in the chat. Okay. So Si and Si plus 1 must have different parities. Now what I can say is that, nice, great. Cool. So now the next thing that I can say is that now consider S1 and S3. So the point is that when Si and Si plus 1 have different parities, the point is that, I mean, the result of this, when Si and Si plus 1 have different parities, the point is that we can say that Si and Si plus 2, S sub I plus 2 have the same parities. So the point is that when Si and S sub I and S sub I plus 1 have different parities, S sub I and Si sub I plus 2 have the same parities because both of them have different parities with S sub I plus 1. So what is their average? I mean, the average can be, when they have the same parity, it means that their average can be added to the sets. But we said that everything that is added, that can be added, is already added. So what does that mean? What does that mean in our equilibrium? So we now say that their average can be added. Their average can be added to the set, right? And also we said that everything that can be added is already added. Everything that can be added, everything that can be added is already added, right? Thank you. Yeah. So everything that can be added is already added. So that means that the average of Si and Si plus 2 is equal to what? Can you say that? The average can be added, but at the same time we said that we're stuck. We cannot add anything further. So what does that mean? What is the average of Si and Si plus 2? Because they have the same parity. Exactly. Their average is S sub I plus 1. Exactly. The average is definitely S sub I plus 1. So what does that mean? It means that if S sub I plus 1 minus S sub I is equal to X, S sub I plus 2 minus S sub I plus 1 is also X. It also means that because S sub I plus 2, because I is not a constant, I is a variable, so I can also be I plus 1. When Si plus 2 minus Si plus 1 is equal to X, it means that Si plus 3 minus Si plus 2 is also X. Because Si plus 2 is the average of Si plus 1 and Si plus 3. And so on. So the point is that the equilibrium, I mean the point that we cannot add anything further. I mean the stable points. When we have some sets and we cannot add anything further to it, in these points, the difference between each two consecutive numbers is set, it is some x, and x is an odd number. Because if x was an even number, then again we could add something between S1 and S2. So this is our equilibrium. No. Si plus 1 minus Si is not necessarily 1. If it is 1, it is good. It means that our set is good. Our set is brilliant. But it is not necessarily 1. I said that consider that we have a set and we add elements as much as we can until we stop, until we cannot add anything further. I want to now look at how the set looks like when I add as much as I can and I cannot add anything further. When I add as much as I can and I cannot add anything further, it means that I showed that first of all Si and Si plus 1 have different parities, and then Si and Si plus 2 have the same parities. So their average can be added to the sets. But I said that I cannot add anything further, which means that everything that can be added is already added. Therefore, Si plus Si plus 2 divided by 2 is equal to S sub I plus 1. This shows that, first of all, this shows that S2 minus S1 is going to be equal to S3 minus S2. S4 minus S3 is going to be equal to S3 minus S2. And so on. So the difference between each two consecutive elements is the same value. And also we said that because they have different parities, each two consecutive numbers, this x must be an odd number. So the point is that if x is 1, our set is brilliant, it is good. If it is x is not equal to 1, if it is, for example, 3 or 5 or 7, etc. Oh, I was not showing this. If x is not 1, then it is not brilliant. So the point is that because the difference between each two consecutive elements is an odd number, and they are all the same, if x is equal to 1, it means that these numbers are consecutive and it is brilliant, otherwise it is not brilliant. Okay, we will discuss that in the future. In the next topic stream, we will discuss these questions. Yes, also Ericto server can be really helpful. Okay, so now if x is equal to 1, it is brilliant. If x is not equal to 1, it is not brilliant. Now what is the point? The point is that, again, this is kind of number theory as well. I guess that maybe the one who have made this contest has designed, the authors of the contest have a strong background in mathematics. I guess maybe they were in IMO, etc. Because in most of the problems you see number theory. Again, in here, it's like we can see that if we consider a set of numbers, we can just see that what is the difference of each two consecutive numbers. For example, if the difference of each two consecutive numbers is divisible by 5, it means that all the numbers have the same remainder to 5. Then, when we reach this stable state, our x is going to be really 5. So the point is that you need to see the GCD of the differences between each two consecutive numbers. If that is, and then remove 2's from that, because 2's are not important. Only the odd part of this GCD is important. So when you consider a subarray, you only care about the GCD of each two consecutive, GCD of the differences between each two consecutive elements. You only care about this, right? You only care about the GCD of the differences between each two consecutive numbers, and you do not care about the powers of 2. You only care about the odd parts. And if that odd part was 1, it is good, otherwise it's not good. Otherwise it means that this set is not brilliant. So in other words, let's make another array out of the array we have. In this array, let's keep the differences between each two consecutive numbers. It's like in here we want the number of intervals such that their GCD is 1. Do you agree with this? It's like we want the number of intervals that their GCD is 1. And there are many ways to calculate that. I think we can either use segment tree or we can use RMQ, and we can use a BS over it. For example, we can use a BS plus RMQ. I have not implemented it, but this is what is in my mind. For example, we can use a BS plus RMQ. When we fix an L, we can use binary search on R and find the first R such that the GCD from L to R is going to be, the odd part of it is going to be equal to 1. In our RMQ, we can in all of 1 see that what is the GCD of this part, and we can also in our RMQ ignore the powers of 2, so that it will remain, it will return only the odd part of the GCD. And then when we have a GCD, we can just see that if it is 1 or it is not 1. And then we can find the best R for it, and this way we can easily find the answer at the end. Is it clear? So the main point that I was saying is that only if you consider the differences between each two consecutive numbers, I believe that if you take the GCD of these numbers, if the odd part of it is 1, it's okay, you're good. Your set is brilliant. So this is what I was saying. And you need to handle the case for equal elements separately. It's okay even if you don't handle it, because if you have two consecutive elements which are the same, the difference is 0, and 0 has no effect on GCD. And if they are at different indexes, again they have no effect. So I guess even if you do not handle that, they won't have any harm to our final answer. So, is it clear, guys? If it is clear, please again use this emoji or put a plus in the chats. And if it is not, let me know. I have not implemented the problems myself, but yeah, I can see if others have implemented. And if there was a code that was implemented with the same idea that I was explaining, I will add them to the descriptions. Yeah. Okay, nice. Any further questions or comments? Let's see when is the next contest. The next contest is in September 1st. And who has... Suistag has mentioned me in the comments. I will check that out after the live stream. Okay, guys. Do you have any further questions or comments? Are you talking about problem F? Yes, tutorial is also released. Well, in problem F, yeah, I'm saying that, for example, in here, if you consider the differences between each two consecutive numbers, for example, the difference between these two is 2. The difference between these two is 3. The difference between these two is 4. These two is 5. These two is 6. So it's like our difference area is going to be 1, 2, 3, 4, 5, 6. Sorry, 2, 3, 4, 5, 6. And then you want the number of intervals in this array such that their GCD is equal to 1. And in order to find that, you need to find for each L the first R such that the GCD of this interval is going to be 1. If you can find that, then the problem can be easily solved. I mean, because if your GCD is equal to 1, that stable state that you will achieve, your X is going to be 1 in that stable state. So you need to find, you have this difference and you want to count the number of L and R such that the GCD of them, the odd part of their GCD is 1. 2 doesn't matter because that X, in that X that you have, you can easily remove the powers of 2. So only the odd part of the GCD matters. So you can see that the point is that no prime number, no odd prime number must be divisible, must be, all the numbers should not be divisible by the same odd prime number. And you can easily check that with an Rnq plus Bs, you can find the best R for each L, and using that, you can find the answer easily. So for each L, you can find the first R that works, and all the R's after that will work as well. Is it clear? So why why the scroll does not work? Thank you a lot for joining the stream today. Yes, very soon we also have topic streams on segment 3 for sure and RMQ for sure. I mean, we're gonna have each week we're gonna have a topic stream on one topic. So right now you sometimes ask for some resources to learn something, but I haven't had recorded the topic yet. But I hope that in the future, very soon, when you ask these questions, I can send you the videos that I have covered all those things so that you can easily go watch them and learn those topics. So for now, maybe you can use USACO guides or something like that. For example, USACO guide can really help. Yeah, I will also do number theory stream very soon as well. And yeah, so for now, maybe USACO guides can really work. You can really help you to learn those topics. And for the problem, you can search in Codeforces blogs. Yeah, but soon in the topic streams, we will cover all those topics as well. Nice. So let me also write it here, USACO guides. And guys, again, feel free to join our Telegram channel or our Discord server. And if you wanted to do any further discussion, you can do that in there. This is the link to the Telegram channel. And this is the link to this is the invite link to our Discord server. Okay, and thank you. But shouldn't the difference array? No. It doesn't need to be in a sorted way, because if the GCD is something, if you calculate it in the sorted way or in an unsorted way, again the GCD is gonna be the same. If all of the differences are divisible by 3, either if you calculate these differences in the sorted way, or you calculate them in not in the sorted way, in an unsorted way. In both of the cases, the GCD is going to be the same. I mean, the GCD of those numbers is going to be the same. So you don't need to sort anything. Don't worry about that. You do not need to sort anything. I hope that I clarified it. You just keep them in the order that they are right now. Okay. So I hope that everything is clear now. Thank you very much. And thank you a lot for joining this live stream. Hope to see you in the next live streams as well and in the topic streams. Thank you guys. See you next time. Bye bye.